Hi everyone. I wanted to welcome you to another installment of the Autodesk Moldflow webinar series. Today we've got a lot of great information for you guys regarding the new release of Moldflow Synergy 2016. And we have the product manager here with us, Hanno van Raalte, and he's going to be discussing all the great new features in here and answering any questions you might have on these new features or anything else that might come up. So I'm going to briefly talk a little bit about the webinars. As I mentioned, if you have any questions throughout this webinar series, feel free to type them into that question box on the WebEx meeting, and we have people in the background that can help that, and we might even just bring it up to Hanno depending on if it's a new discussion topic. And then also this slide deck will be available for download after the presentation at the following link, and we'll also be uploading the entire webinar to YouTube for you to view later. All right, so if this is your first time joining the webinar series, we try to do these about once a month for each product. So each week is a different product, either simulation Moldflow, simulation CFD, simulation mechanical, or else simulation composites, now known as Helios. So what the webinar is it's a monthly technical discussion where we either give you demos or discussions followed by QA sessions just on different topics between the products. For instance, this time it's what's new in Insight 2016. And listed there are just a couple of the past ones we've done. Some of the most popular ones that we've seen users viewing on YouTube are performing DOEs, matching simulations to reality, and then compression and injection compression molding. And also listed there are a few of the future ones, such as the one that's today, and then a couple others in the coming months, deeper dive into what's new, as well as SimStudios to Moldflow troubleshooting. And to sign up, you can always go to the forums. We post those in there to register at. Most of you got direct emails. However, you can also get it through autodesk.com/helpwebinars, and then also the SimHub events website. And the Simulation Hub is a great resource for learning new information about the products, the simulation products, and then as well as access to webinars and so forth. And listed there is the YouTube channel that I mentioned earlier. It's under Autodesk Sim 360, Build Your Simulation IQ, and we post all these webinars to that, even for the other products, so you can browse through that for all those. What's in the news? This is just kind of a brief overview of kind of what's in the news and what's new and upcoming for simulation Moldflow. So as I mentioned, 2016 has been released. So you should all, if you're on subscription, see serial numbers come in for those products, as well as being able to access those through the Autodesk accounts website. Autodesk account actually replaced the subscription center back in March, so that's kind of a new landing site for where to download your products, where to manage your users and so forth. It's a great resource to check in on that, even for support. And one thing I did want to mention is there was a repackaging for Simulation Flex. So if you're using Simulation Moldflow Flex 2015, we actually repackaged it for 2016 so that it just includes Simulation Moldflow Flex rather than previously it would include simulation mechanical, CFD, and Moldflow Flex all combined in one installation. So this way it kind of branched out just so you can only get what you really need for downloads. What I also mentioned was the knowledge network. If you go to knowledge.autodesk.com, that's where we post a lot of great articles either for how to use products or troubleshooting through them. And as you can see there are a few links there for popular articles that were recently written, including that Flex offerings, just explaining it a little bit better, as well as some training videos and troubleshooting. And at that, I'll go ahead and turn it over to Hanno. And as I mentioned, feel free to ask us any questions throughout the presentation, and we'll be happy to answer them.
Yep, thank you very much. And let me grab the share. Yes. I'll show my screen. All right, good morning, everybody. Thank you for attending this webinar. Give me a second, I just have to switch to the right presentation again. This is the one. So I'll be presenting like what's new in the Moldflow 2016 release. This is by far the biggest release Moldflow ever produced in its history. So we had a phenomenal amount of contributions from all over the world, like our users, in terms of what features they would like to see improved and how some of the new capabilities that we're including in the release, how they should function. So we had a lot of feedback on that. I'll touch on it a little bit later. But like I said, this year's release is an incredibly large release. Yesterday we had a user meeting in Lowell, at UMass Lowell. We went through the full presentation of what's new in the software, and I think it took us about a good 4 hours to get through the entire slide deck. Now I have 1 hour, so I have a condensed version of the slide deck. I will not be able to get through all the individual features in great detail. So, but as was mentioned earlier, feel free to ask any questions during the presentation. I'm happy to answer any of the questions that you might have. So, really quickly going over the agenda, I'll go some of the usability improvements, meshing results, some additional processes that are become available below, interoperability with a new tool called SimStudio tools, and some of the enhancements that are in Advisor and Moldflow Flex, and some other additional information that you might find useful. So, starting off with that. This year's release has an incredible amount of like smaller and larger improvements in the in usability, and to a great extent, one of the biggest sources that we actually we use for that for like getting all those improvements in the software and help us identify which ones are impactful and which ones requests are sort of nice to have was the idea station. So. The idea station provides a forum for people to request certain features, but also methods for providing kudos. So, for instance, this particular request is entered by someone, and then you can actually add your support to that request. If it's useful for you too, you can add your support for it, and that provides a way for us to look at the highest impact features to address. So this year's release, I think out of the top 10, we had a good amount. Actually, the top 5, I think, had 3 out of the top 5 requests were coming directly out of the idea station. And 18 in total, 18 ideas have been implemented in this year's release. So this is a very, very good source for us to actually get input from you guys as users on what you would like to see improved. So this is an area where we put a lot of focus in. So I would seriously encourage anybody to spend some time on entering ideas, but also to provide support in terms of to other people's ideas. Another thing that we've done in the last year is we have a really good user experience team now. So and user experience team basically helps us identify how a certain feature should work. Now these are people that some of you actually have interacted with over the last year, like Caroline Doran, Stephen Gu, and Peter Maxfield. And this is actually part of a larger team in Autodesk that really is all about understanding how people interact with the software and trying to optimize our workflows and such. So over here you see a little video of one of the things that we do in terms of research. We actually do eye tracking and mouse tracking. We have somebody go through an exercise, customers go through exercises, and we record those sessions and actually find out where people are looking, where people are pointing their mouse pointers, so we can optimize the minimize the amount of mouse travel and make it easier for people to find what they need. So the results of this actually are not necessarily impacted this particular release, but it's certainly something that we're looking forward to in the future. The point for this is basically we had over 800 customer interactions this year only with getting feedback and direct input from the user community into this release. So thank you for those of you that have interacted with us and provided input into this release. This is extremely valuable. Now, when you install the new Moldflow 2016 release, you will see as soon as you open the software, like there's a new Moldflow landing page, and this is something that we have been working on for the last year or so to build out our own community page effectively. So this is an area where you can post videos, things that are of interest or useful for you. It provides links to the discussion forums. You can look at what user events are taking place maybe in your area, so you can sign up for those. And there's some other information that's below that we actually off screen a little bit right now. But this is an area that we want to basically use for communicating with you. If there's something of interest to you guys, we want to put it over there and take that as a good place for us talking to you guys and get your feedback. Another thing that we introduced this year that's been highly requested, I know you guys travel a lot, is the ability to borrow a license. So if you have Synergy, Advisor, CAD Doctor on your machine, and you want to, let's say, travel to customers in China, you want to need to bring your product with you, you can go to the Help About box, hit the check license information, and over here you can actually start looking at borrowing that license for a period of time. So that license will be checked out. You basically will be temporarily located on your machine, your laptop. You can bring it to China and use the product at that point. This is not available for the inside solver. The license type that the inside solvers are on are not compatible with license borrowing, but all the other products are compatible with that. So we made a lot of changes in improving the look and styling and effectiveness of the UI. So one of the things you're going to get very familiar with or very useful very quickly is the fact that as of right now, all the tabs are on all the time. So not where in the past release that you would have to click on the results first before the results tab would open up. All those things are right now available from the get-go. Also, you can combine and move certain panels in a bit more efficient way, so you can customize the way you like your user environment to look. Some other things that we added this year's release is the ability to actually show the study name on this particular window. So there's new additional control options. You can switch on and off a couple of more UI elements, like the study title would be displayed over here, but you can also switch off the view cube or the GNOME in the bottom over here. So provides a lot more flexibility in how you want your user interface to look. We also improved the speed of the user interface significantly. So we updated a number of components from older versions to newer versions, and then that actually gives us an enormous amount of speed improvement. So post-processing, model loading, building up of animation is probably 2 to 3 times quicker now than they were in the past. So this is obviously very, very useful if you use larger models. I mean, we see more and more people starting to build larger meshes. So that's the speed of the post-processing is an incredibly important piece for keeping up the speed with that. An additional thing that we added to our yep. Yes.
Oh, sorry. We did have a quick question related to actually borrowing licenses.
Yes.
A user asked if you have to borrow the license on the client machine, nothing to do with the server machine.
Correct. So if you want to check out a license, you let's say install the software on your laptop. You do the borrowing explicitly from the laptop at that point. So you go into the help about from on your laptop and check out the license from there. You don't actually have to interact directly with the license server itself. What happens basically is that temporarily your laptop becomes a node-locked license server for this particular application. Does it help?
Yep, thank you.
Okay, all right. So if for those of you that use valve gates, so in the past it was always actually it was impossible to see which elements would have valve gates associated with it, or even like be able to see like if it's the first what the controller was associated with it. So it was very like you don't always have to like sketch it out on a piece of paper to keep track on what's going on. So in this release, we actually allow you now. We'll actually display now if you position a valve gate, position an icon or a glyph that highlights the fact that there's a valve gate associated with this particular gate. We'll also color the gate itself in a teal color, and you can also switch on the valve gate controller name. So if you were to name your valve gate controller 1, 2, 3, or 4, because that's the way the sequence that would open in, it would actually display it that way. So much easier for you to understand what's going on in the model and make sure that the model is set up correctly before you run it. One of the biggest features, and I think you're going to get very quickly used to this, is the fact that we have reorganized or redeveloped our layer feature set. So we see more and more people coming in with assemblies or many more components that need to be coming from CAD and have to be meshed and such. And that became a fairly hard to organize in the layer pane. So now this year we actually come up with the fact that you can create a folder structure in the layers, and you can move your organize the folder structure the way you want to. You can put certain components into it. Let's say if you want to have, let's say, these 3 layers moved into a new layer, a new folder. You can move that with drag and drop, multi-select, and you can actually unselect an entire folder to actually, if let's say, if you were to unselect this folder structure over here, every layer in this hierarchy would automatically be unchecked. So you don't have to go through a layer by layer unselection of layers. So much more efficient, and I think you're going to get used to this very, very quickly. Another piece to this particular thing is that there's a new tool that we developed over here, and it looks like a flashlight. And if you go over if you select the flashlight over here and go over the layers, it will actually show in blue which pieces of the mesh actually are associated with this layer. So if you hover over this, part of all the elements in that particular layer would highlight in blue in the model, and it also works the other way around. So if you were to select an element over here, click on the highlight icon, it would actually jump to the element that actually where the elements actually are in. So much easier to find out which components are in which layer and such. Additional to this, so if you bring in a CAD model now from, let's say, ProEngineer or SolidWorks, and it has multiple bodies into it, we automatically include the name of the original components from the way it's called in Pro-E. We transferred it also into Moldflow. So where in the past it was called Body 1, Body 2, Body 3, CAD Body 1, 2, 3. Now it will be called parts, mold, or whatever you named it in ProEngineer. So that makes the connection with the CAD model a heck of a lot easier. This talks to that exact same thing, but also the fact that if you actually take a model from, let's say, your CAD environment, in this particular case it's Inventor, but it works the same way with ProEngineer or SolidWorks. And there's a certain colors applied to that particular model. If you import that model into Moldflow, if we have the information available, you would also take the exact colors across to the product. So the way the colors look inside of your CAD system will now be the same as what it looks like in Moldflow. Makes it easier for people to recognize the different components. Also, the import speeds are significantly faster now. We have some new components that we brought into the software, and it makes it a lot quicker. And I think the quality of the translation work that's done is significantly up from where it used to be. This is another one that came out of the Idea Station. The ability, and this is actually number one, I think, on the Idea Station right now, is the ability to copy settings or material data from one study to the next study. So let's say you have you run a model, you decided like you needed to have a model change made, you went back to the CAD model, made a small design change, bring the same CAD model back into Moldflow. Rather than having to set up the entire model again from scratch, you can now copy-paste the different components from settings from the first study and apply it to the second study. So that avoids you to do a lot of manual work and setting up the model in exactly the same way, as well as it avoids some scope for discrepancies in the analysis settings that you might have missed. Yeah, so I think this is another big one that's going to make your life a lot easier. This one came also from the Idea Station. It was, I think in the top 10 somewhere. The ability to access logs without actually opening a study file. So, and this is particularly useful if you have a large model. So every now and then you want to look at the log file without having to open the model, because it takes maybe sometimes, if you have a large model, a minute or so to open the model, and it's just wasted time. So in this release, we allow you to open the study notes as well as the log files directly from in your study tree, or in case, let's say, from your job manager. So you can also open the exact same log file from your job manager in a new window without having to open up the model directly. I'm going to go over a number of the meshing improvements that we made. So one of the first things we did this year is and this is a result of a usability study. We basically had a number of people go through a specific exercise, and one of the things we found out is that people have had a hard time actually using the 3D mesh repair wizard. And just in looking into why that is, we basically concluded that there is actually there was almost no correlation between what a customer was, what you would do as a user in terms of fixing a specific mesh, and getting feedback in terms of what the impact of the fix was on your overall mesh quality. So we've completely redesigned this mesh repair wizard, and have on the top level now a good overview of where the problems are, and we allow you to basically just go down to the specific components and try to fix those and individually. So there's a good correlation between the items you're fixing on an individual basis and the impact it has over the overall mesh quality. Also, we have now better ways to isolate the specific errors or like the defects in layers, and to zoom in on those particular problem areas. So usability improvements on this particular, I think, is going to be very good, and we hope that people are starting to use this a bit more, because there is a good amount of value in actually fixing this mesh through mesh repair wizard. This is another thing that actually came through user meetings initially, but I think later on became an idea station item as well. In the 2015 release or older, if you had, let's say, you wanted to model, you had a model of a cup, and you needed to select the inside of the cup, let's say the bottom of the cup. It was always very hard to actually do that selection, because you had to cut through the part and do some tricky things to actually make the selection of the bottom possible. Now, in this release, we allow you to basically select one element on the bottom and basically find every element that is connected to it with an element in the same normal direction. So you can actually select large areas that are connected and oriented the same way, that from a CAD perspective you would expect to be functioning in one and the same way. You will be able to select those very quickly now. Another thing we did is made some improvements in the preview ability to preview the nodes of a remesh area. So if you now do a remesh, we can now see where the nodes are going to be instantaneously. So before you actually apply to the remesh operation, and it helps you to understand sort of, is this remesh too fine or too coarse. So I think it's going to be very valuable for you too. The other thing you will notice is that we actually have changed some of the default mesh settings that we had in the meshing wizard. So we noticed that typically the meshes that we created, the default mesh size that we put in there was actually relatively coarse, and we were not happy with the mesh quality we were getting out of that. So we made a change to reduce the default edge length that we calculate. As a result, we will get a better, a larger element count for sure, but it actually is probably what most people were doing anyway. Sort of reduce the edge length by about a third of what it was. At least I can absolutely say that that's one of the first things I would do typically to bring it down a little bit. So it's less aggressive in terms of meshing strategy and focusing more on getting a good quality representation. So I'll go over some of the new results that we're creating and some of the changes we made in the results. So one of the most visible new And that helps us to understand sort of how material flows through a cavity. So if you were to, you'd have to look at this as how do particles that are ending up on the surface, where did they flow through, and which areas were they flowing through in a specific point in time during the molding process. And it helps you to sort of basically trace back, if you see a visual defect on the surface of your part, it helps you to trace back where the defect may be coming from, because the defect might be on the surface somewhere, but the actual underlying cause of why the defect occurred might actually have been picked up during how that plastic actually arrived at that particular area. So we show you in particular case the path those particles that are on the surface now are, the path they took to get there, but also you can overlay things like velocity or the temperature or the shear rate. So we hope you to be able to see maybe excessive shear heating occurring in a specific area that might actually cause a visual defect on the surface. There's a couple of ways we can represent this particular result. In the right side of the screen, I have what we call the tube display, and at this stage we're displaying everything how the part fills. There's another alternative way, like as lines, which is a bit thinner, and one of the other alternative ways to display this is through what we call markers. So basically we follow effectively markers of things that represent particles, how they enter the cavity, when they enter the cavity, and how they end up on the part surface. And it gives you very, very interesting ways to display certain things. In particular, you can see over here how clumps of material basically, when they enter the cavity, get really, really stretched, and then how they, for instance, start like consolidating again. Another way you can actually use this particular result is by, in the right side of the screen, basically we show all the markers, how they come into the cavity, but another way, and this is how we did it on the left side of the screen, is we marked off certain areas on the surface of the part and basically just isolate how those particles on that surface where they came from. So I think that may be the more useful way of looking at the results personally. But depending on what you're looking at, you might find a preference for using either one or the other way of representing this data. So in a sense, there's no new data generated here. It's just a very different way of displaying things, and it can help explain certain things that can be explained maybe with 3 or 4 other results, but this is just a much easier to understand results, particularly for non-Moldflow users. Another very useful result you're going to find is the ability to calculate the 3D weld lines. So we have 2 results actually we generated right now in 3D. It's basically the position of weld lines at forming, but we also, once the weld line is created, we also follow where these weld lines are moving towards. So in this particular case, we see that a weld line is formed because we're having polymer flowing around this hole over here, and some parts of the weld line actually stay stagnant because no material is underflowing anymore. But it's a very significant part of the material will actually streak away, and the weld line actually will. The material that was initially forming the weld line will actually have moved into other part of the cavity. So what you can conclude from this probably is that this area probably has had significant underflow, or that weld line is probably going to be pretty good. While on the far end of this, we actually see a weld line forming over here that actually does not move, and that's going to be a stagnant weld line that will not have had any mixing going on at that point in time. So that weld line is probably significantly worse than in quality than the weld line over here, from a structural perspective at least. So These results can also be exported as XML files, and I think down the line they probably can be used in interfaces to structural programs as well. This is another one that actually I think is going to be super useful. So if you brought in your CAD model in as a CAD solid model and you run a warpage analysis on it, we can now use the deformed mesh from, let's say, your dual domain or your 3D model, the warp mesh, to morph the original CAD model into basically complying with the deformed shape. So the way that we can use is basically export the actual CAD model as a warped CAD model, and you could possibly use it in, let's say, try to prototype that particular warped part and maybe see how it fits into an assembly in reality. Another way you could possibly use this is basically export the windage, sort of the opposing warpage, so you can actually build your CAD system, your tool around that as a windage model. So particularly to this last the windage model, you would use the opposite over here. Then we typically don't see people using like the full warpage, but like let's say 70% of that particular warpage, because like the actual deformation causes some extra structural stiffening of the part, if you will. So typically people don't apply the full opposite warpage, but like a portion of it. So there's two CAD formats that are going to be available as export. I believe it's SAT and STEP, I believe, are the file formats where we can actually export into. So in this particular case, we have actually two models that are overlaying. One is the CAD model of the original model, and the CAD model of the warped shape, in green. Another thing that actually came, I think maybe even through the idea station, is the ability to animate an XY plot. And an animation of an XY plot is not necessarily all that interesting, but the ability to actually combine it with, let's say, overlay it with the, let's say, fill time plot, you can actually see more or less how the pressure, for instance, in a particular case at an injection location correlates to what's happening in the mold itself. So you're using the fill time plots to create an animation together with the XY plot. So it makes things, the understanding of the analysis a lot easier to see. So particularly for people that are not necessarily Moldflow experts, this is going to be significantly easier to understand what's going on. We also added a new result. This is actually particularly was introduced for the request came in initially. It was very centric around the MuCell process, where weight savings is a big piece, a big component of what people want to achieve. So we actually created a new result, was basically called part weight, and now we track sort of the weight of the part as it fills. You can look at multiple cavities in different way, and once we actually did it for the MuCell process, we actually applied that also to the other analyses results. Just the normal filling patterns actually can use this now too. And this can help you actually also look at making sure that the cavity weight of your multi-cavity mold, for instance, is evenly distributed. So, and if not, then you actually have a way to. It's probably worth looking into why that actually the imbalance would actually happen. This is another result that actually came through the idea station, and I'm pretty sure a lot of it you are going to find this very useful. So in this particular case, we have 4 different scenarios lined up. We locked them, and now we are looking at the warpage display or pressure at switchover, and click on one particular window, and all the other positions in the locked windows will actually be queried at the same time as well. So we examine, we do the actions in one window, and in all the locked windows we see the exact points being examined too. So easier to understand sort of which design is better, A or B, just in general helps you with the comparison of the results. In prior releases, you'd have to click it in each individual window, and actually when you were switching from one locked view to the next, in the first window the result would disappear. So now everything is available on screen at all times, so a lot more useful, I think. This is also extended, by the way, to the warpage examining, which is a bit more, we actually created a new window for that, so that has undergone some changes as well. So I wanted to talk a little bit about new processes that we've introduced. In prior releases, if you were using valve gates, you had two choices. You would open or close a valve gate, and the opening of the valve gates and closing of the valve gates would always be instantaneous. Now that has, in reality, will result into like acceleration and possibly visual defects of that you will see on the flow front as soon as you open a valve gate. You see like stagnation in certain areas and acceleration in the area that, let's say, you've just opened the valve gate in, while the hot runner system is rebalancing its pressures. So the industry and the hot runner suppliers have actually started to change the way these controls are opening and closing now, with a slow opening of the valve pins. So valve pins are now actually, you can open the valve pin in a very controlled manner that gives the pressure inside the hot runner system a chance to rebalance, and the flow fronts coming out of the hot runner at that point will be will show less hesitation and less acceleration. In this particular case, we see a lot of hesitation in the instant open scenario. We see a lot of hesitation in this particular area, and a lot of acceleration in the flow front in this other area over here. As soon as this opens, it can also show some spiking in temperatures at that point, where in the slow opening valve gate scenario, the flow front progression is much more stable, and you hope to avoid a lot of the visual defects that you might see otherwise. So this is bringing in technology that hot runner suppliers like Synventive, Inco, and HRS Flow have at least been implementing in their hot runners. Induction heating is a technology that actually has been starting to become make inroads, I think, also in the United States. But it's a technology where you build induction coils inside the mold. For you, those of you that are familiar with induction cooking stoves, that you will know that heating up your tea kettle to a boil on an induction stove is incredibly quick. Now, the great thing about the same similar technology is now also implemented inside of the molds, where you can build induction coils into the mold, and when you switch those induction coils on, you will actually heat up the surface of the mold very quickly. So that when you heat up the mold above the transition temperature, at that point you and then inject the plastic into it, you get a really good surface quality finish in your on the side where the mold is at above transition temperature. Now, the heating actually happens very quickly. So just in a fraction of a second, that tool will be heated up in the location where you close to the mold surface temperature. So, but it's a very local effect, which means that like you don't actually have to cool the entire mold down, which is something that you actually would get with more traditional rapid heating and cooling technologies that are out there. The other benefit of the rock tool technology or the induction heating technology is that the temperatures actually where that you can achieve with this are like much higher than you can with, for instance, and then your steam heating or your heating cartridges. So the company that brings it to market is a company in France called Rocktool, and they actually started making really good inroads in the United States as well. So they had a really good exhibition at the NPE where I think 2 or 3 places were actually showing their technology live on the floor. Just phenomenal. I think particularly also with in combination with processes like MuCell or other foaming technologies, the Rocktool induction heating technology can still create a high class A surface finish even with foaming technology being applied. So very interesting technology. And certainly something that's unique to Moldflow right now, and a technology that we probably see a lot more for in the next couple of years. This year also we added some new capabilities in our MuCell technology. The microcellular injection molding space is like becoming more and more interesting for our users, particularly in the context of lightweighting products. We extended, so we actually added a new nucleation model to our existing capabilities that now make the results coming out of MuCell analysis actually more plausible or more easier to work with than in the past. In the past, you had to understand like how many nuclei you're going to get and how big these nuclei would be, gas nuclei would be at the beginning of the analysis, and that's something that really nobody could possibly know. So what we did this year is we actually added a new nucleation model that calculates the number of nuclei and the size of those nuclei during the analysis. So it's completely process induced like it actually is in reality as well. So we also added the new MuCell capabilities into our 3D code. So in case you actually are working with more chunky or parts that have a big transition between thin and thick walls, the new 3D MuCell code might actually be something that you might want to look into as well. So a lot of the parts that actually are being produced in reality or with MuCell technology are at the moment still conventional thin wall parts, but there is scope for we're actually changing designs to be more MuCell friendly and get, say, gate in thin areas where like that's typically a big no-no in typical injection molding. But like I said, we will probably do this is still an area that we're going to add some more functionality to in the foreseeable future. Another thing we did in this year's release is added the conformal cooling, full conformal cooling now completely within Moldflow. So whereas in the releases until now, the 3D flow inside of the cooling channels could be done, but it required an Autodesk CFD license for both the solver as well as the design study environment, so the user interface. In this year's release, the entire mesh generation as well as the solver are completely done within Moldflow and do not require the CFD product to be licensed or installed with the software. So the technology is available at the premium and ultimate level right now, and so if you have that, you can it's completely available to you to start running as of day one. Getting close to the end of the presentation, I think, right now. So this year's release also includes a new tool that, to the Moldflow product portfolio. It's called SimStudios tools. In prior releases, you might have used our Inventor Fusion product that's we've had in our product portfolio now for the last 3 or 4 years. That product line actually had actually been redeveloped completely from scratch, and now it's actually been brought. Parts of those are actually brought into the Moldflow or the simulation portfolio now. So we actually have now a flavor of that Inventor Fusion technology that had been redeveloped, and we built some new tools on top of that to help create models that are analysis ready. So if you bring in a CAD model now from, let's say, Pro-E, this is a tool that can help you with defeaturing, simplification, and solving some of the problems you might see in your CAD model. So it has some really good capabilities of repairing CAD models in a very quick and easy way, similar to what you typically have been doing with maybe CAD Doctor. Having said that, CAD Doctor still has extremely powerful tools for for manual repair or like automated repair as well. So we probably will not get to the level of what SimStudio tools. SimStudio tools will probably not be at the same level at the moment as what CAD Doctor has. So CAD Doctors will still have very, very unique and incredibly powerful tools for repairing CAD geometry. So this is for the inside product portfolio a bidirectional workflow. So you can go from a CAD model in Moldflow to SimStudio tools, make your design changes, bring the model back, and it automatically will update the original study file with the new CAD model, or create a copy of that. With the Advisor product, this is a tool that is a one-way direction. So you start in SimStudio tools and bring it into Moldflow Advisor at that point. I see there's a question. Is that something that you want me to answer?
Sure, if you'd like. I believe Harold asked if Fusion is still accessible through Moldflow, even though SimStudio is now being installed with it. It says he sees a few bells and whistles that Fusion had that SimStudio doesn't. So he's a little worried about that.
Well, actually, happy to talk to you about that, Harold. Which features you'll be missing. It does not. Fusion does not ship with the product anymore. So that code base that Fusion had has actually not been maintained for the last 3-4 years, and it's certainly something that's we see as something that's a viable tool going forward. So if there are certain missing capabilities, we'd be happy to have a conversation to see what's missing in your perspective and see how we can bring that back. Good. If there are more questions, we can take that later. So I was going to go over some of the things that have changed in the Advisor product line and the Moldflow Flex product line, although that was some of that was discussed in the top of the hour. So in this year's release, we will be adding the ability to view fiber orientation results inside of the Advisor product in the exact same way as we do in the inside product line. So this has been something that our Advisor customers have been asking for a long time, and the same goes for the warp display results. So now we actually will show you the amount of warpage that occurs in the part, where in the past it was you'd have to look at how much shrinkage would occur between certain points and derive whether or not that's within tolerance. So that's still possible. That the old workflows are still possible, but we now also have the ability to actually explicitly show the amount of warpage that we predict, just like you have in the inside product line. The focus on this is still primarily like to be able to compare designs, like if the design A or design B, or gating location A versus B, which one will warp more or less. That's still exactly the same as it used to be. but you can have now a bit more handle on the quantity of warpage that is occurring. For the Moldflow Flex offering, I think in the next slide I will talk a little bit about the repack. Oh, actually no, I think the repackaging slide I took out because it was already talked about earlier. But one of the things we've done, we actually updated the machines that are in the cloud. The machines in the cloud actually have been refreshed, have now a lot more memory. I believe 256 gigabyte of memory are available now, and they're like significantly faster than before. So you will see, if you're using Moldflow Flex, you'll see a very big tick up in analysis speed, I hope. So some other things I think that you might find helpful. I think some of this was actually already used or mentioned in the early statements. The links and resources to access the help, I will not go into all details over here, but there's a lot of information that you have access to in terms of blogs, SimTV, the labs, and such. And another thing I wanted to point you towards is there's a new technology preview that we made available as of 2 weeks ago. It's a new technology preview called Harmony, and it's a technology preview that's focused around the generation of a 3D mesh. We basically use some technology that we've used in other components that we've brought to market in the last couple of years as a simulation organization, and apply them to Moldflow. So where Project Harmony basically allows you to bring in a CAD model from any source right now, with the exception of I think Inventor. I think it's right now not something that's supported, but we'll fix that. You bring in a CAD model, and the point of it basically is that it should be able to read a CAD model and as well as mesh it, even if the CAD model has some defects in it. So if there's overlapping surfaces or flaws that would prevent our normal meshing procedure from proceeding because the CAD model doesn't quite work, Project Harmony will basically do what they call a shrink wrap of the outer shape of the part, and actually use it as a basis for the mesh generation. So the other thing that it does is basically it uses some different. We're trying to get away from you as a user needing to provide all kinds of information about which area you want to refine and which areas you want to mesh coarser, and have to work that all by itself. So in this particular case, you find areas that are like flattish. Probably see there will be have a mesh size that's significantly coarser, because they can be coarser over there, and areas that are very detailed, or you see like a big transition in thickness, for instance, or features associated with it, we will refine the element size in a particular area automatically. Now, the interesting piece to this is that it actually creates not only on the exterior surface a very different mesh than what we typically see with our default mesher, but also on the interior surfaces we see, or in interior we see like a very different mesh than what we typically would see with Moldflow. So in this particular case, our My Little Pony that I picked up from an open source Hasbro download page, you will see that close to the surface we actually have a lot of elements, or we actually see more elements than we typically would see in a Moldflow mesh. And in the surface where things are very chunky, you will see like a much coarser mesh being generated. So that's the other piece of this piece, that the technology that we're experimenting with. And we're really looking for feedback in terms of, is this something that you see as valuable or not. The other thing that it does, it has some really interesting ways of cutting through, let's say, the 3D mesh. In this particular case, we have a cutting plane that we can move and drag and drop and rotate by like manipulating these outer boundaries or this particular control point over here. And it actually automatically crinkles, or creates a crinkle cut, we call this, of the 3D mesh. So within Moldflow right now, inside of the Moldflow interface right now, in order to see the interior of a mesh, you have to move things to a different layer and hide a specific layer, and that actually is not very intuitive. And I think this might be another area that I think we might have some good learnings from, to see if we can actually reapply this back into Moldflow. So, and like I said, the focus on this is basically primarily on the ability to create an analysis-ready mesh without too much user interaction, be able to mesh models that are not necessarily can be meshed with, that have faults in them, and that might actually until now always had problems with creating a mesh on. And this particular case, this particular model actually has several bodies into it, and it would not mesh within the standard Moldflow interface, but Project Harmony actually was able to create a mesh in it. And the third piece is basically understands whether or not the mesh distribution that we're getting in this particular model, or with this measure, are they actually helping us out with creating good quality predictions. So we've experimented with it extensively internally, and I think we are very confident this is going to help us move the needle in a significant way. But like we'd like to expose this to more customer cases than we have internally right now. So please. I think that brings me to the end of my presentation. I think I've run a few minutes over. Yeah. If there are any questions right now, I would like to take some time to answer those. In conclusion, I really hope that
great presentation.
Yeah, like I said, this is a condensed version of the full deck. Like if you go through the what's new PDF that we typically do provide with the products, there's so many features in this particular release, and like I said, a lot of them actually have been had input from many of you guys during the development time. So I'm extremely grateful for your contributions in that particular case. So part of this release is also yours.
Great, thanks. We do have a few more questions, but as Hanno mentioned, we are at the top of the hour, so I'm not sure if, Hanno, are you able to stay for maybe a minute or two extra to answer maybe a couple extra questions here? Okay.
Not a problem, I can. Not a problem.
Perfect. So we do have a question just from Mike here. It looks like he's asking about any changes to Advisor in terms of repackaging, since Insight was repackaged a little bit.
No, so the Advisor
Warpage.
No, so the Advisor product is still the exact same the way it was in the past. So with the Advisor product, you have access to the Advisor product as you've had it for many years. But in the last couple of years, I'm not sure if you're aware of this. There's a tool called VFM that was added to it, as in, and that is now renamed into Moldflow Design, and that's really more like a sort of a spell check for people that are actually developing plastic products. So that is included in that license too, and particularly because it's such a designer-centric product, that's the DFM or Moldflow Design product. We decided that it's actually a really good fit for to include with the Advisor product line as well. So nothing new per se, but there is some additional tools that have been around for like a couple of years that you may or may not be aware of.
Okay, great. Next question here from Michelle. They're asking about the validation documents for 2016. I
Yep.
think we're still in the works for that, or
Yeah, so they're being they have been created, but the software developers at the moment we are still I'm not saying rewriting them, but at least pushing them into a more consumable format right now. And I think in the next week and a half, I think we'll be able to publish those. Some of them have reached completion stage yet, but there's a few still that are being actively worked on.
and then we typically publish those to the Knowledge Network. Is that right, Hanno?
So the traditional piece that were replaced that had been posted to was Subscription Center. With the changes to Subscription Center, I still have to actually, so the content that was there in the past is still there. I'm not 100% confident that we actually will be able to post new ones there. So it might actually have to move to the Knowledge Network going forward. So we'll find a place for it, but that's
Okay.
to be determined at the moment.
All right, sounds good. And then I think there was one last question here. A user asked regarding one of the issues that he experienced in 2015 was the temperature drop through valve gates fixed in 2016. So it looks like there may have been an issue with temperature dropping through the valve gates.
I believe I've seen some communication on one particular on the 3D solver that actually is being worked on at the moment. So it's not in this particular release. I think this came in at least as a development piece, I think fairly recently. So it's not in the 2016 FCS release for sure.
All right. And I think that's it. Well, thanks again, Hanno. We'll let everyone get off to the rest of their days. As we mentioned, this will be available on YouTube, the whole presentation, and then we'll also post the slides to the Box website that we listed at the beginning of the presentation. So thanks again for joining us. Hanno, do you have any last comments?
No, yeah, so many of you I've met in the past and know where to reach me, so any additional questions, don't hesitate to contact me directly. Yeah? Thanks very much.
All right. Thank you. Bye.